Often, there is a need for real-time monitoring of protective relays and their power system quantities, such as voltage, current, power, and breaker status. There is also frequently a need to perform control functions, such as manually opening and closing a breaker. The system that performs such functions usually takes the form of a single or multiple computers running a special software package. The resulting system is referred to as a Human-Machine Interface, or HMI. GE Multilin has developed a powerful and easy-to-use HMI software package known as Enervista Viewpoint Monitoring. The objective of this next section is to demonstrate to the student the general capabilities of HMIs. We will do this by guiding you through some of the available features of Enervista Viewpoint Monitoring. The movies that will be shown are selections from the Help section of Enervista Viewpoint. The procedure to create and utilize Enervista Viewpoint Monitoring HMI screens can be broken down into the following steps. After launching the Enervista Viewpoint Monitoring software, we would first set up a communication link between the software and the relay or relays. We already outlined this process in a previous section. If you would like to review these steps, please click on the Ethernet button in the top menu. Then click on the 10100 Base T Lab button on the left of the screen, and then launch the movie titled SR Relay. We'll cover the remainder of the steps in this section of the training CD. First, we'll cover the pre-configured screens called the dashboard. Next, we'll review the processes for creating your schemas, including digital and analog monitored points and control functions. We'll then cover how to create alarm screens, and finally, how to provide security for an HMI. Enervista Viewpoint's plug-and-play screens make it easy to start monitoring your GE Multilin devices immediately. These pre-configured screens eliminate the need for programming and memory map editing to put the data you need to do your job right at your fingertips. For this example, we're going to use the GE Multilin L90 line differential relay. To view these screens, click on the IED Dashboard button on the main menu. In the dashboard, you will see an icon for the L90 relay. Clicking on the Dashboard button will take you directly to the L90 Overview screen. This screen lets you quickly monitor the status of an L90 protected transmission line and view critical operational information for the relay. Voltages and currents at the local L90 are displayed both as analog values and on a phasor diagram. Similarly, current at the remote L90 relay and differential current are displayed both as analog values and on phasor diagrams. Click on the Metering button to get a view of currents, voltages, and symmetrical components for every source on the local relay. On-screen phasor diagrams and gauges make it easy to view the data graphically. The Power screen provides all of the data you need to perform power analysis. Apparent, real, and reactive power values are shown as both analog values and bar graphs for each phase of a three-phase system. Power factor is also displayed for each phase and averaged for 3 phases. A running total of energy consumed since the last reset is also displayed in watt-hours and var-hours. The demand screen allows you to quickly analyze 3-phase power and current demand with historical maximums. Real-time values for per-phase current demand and 3-phase power demand, apparent, real, and reactive, are shown both numerically and graphically. Date and timestamp data for historical maximum demand values is also shown. Resetting stored maximums is as easy as clicking the Reset button. The Contact I/O screen provides a view of all the hardware signals being sent to and from the L90. This panel view shows the state of all I/O points at a glance. Click on the Virtual I/O button to monitor software commands being sent to the L90 and the status of any flex logic equations. This one simple screen provides a complete view of every virtual input and output configured on the L90. The peer-to-peer messaging screen shows the status of all messages being sent between sets of L90 relays. You have now successfully created and viewed plug-and-play monitoring screens for the L90 Universal Relay. Plug-and-play monitoring screens are available for virtually all GE Multilin digital devices. To generate and view screens for other devices, simply follow the same procedure. The OneLine Editor allows us to create the custom screens for our HMI. Along the top and sides of the work area, you should see various toolbars containing an assortment of tools. The tools can be dragged into a floating window, or they can be dragged to other areas around the workplace area. Should you wish to hide or add other toolbars to your work area, you can do this by clicking on the View menu button above, clicking over the Toolbars option, and then selecting a toolbar to open or close. We will assume that you have configured your sites and devices properly. If you have not done so, please refer to the Site and Device Setup tutorial. In this tutorial, you will learn how to transfer a paper-based schematic into an Enervista schematic using the System Editor. As a goal, we will be trying to build the following schematic. Let's give our schema a title. Start by clicking on the text icon, and then click on an area to place the title text. Now, let's edit the properties of this text box. Right-click on the text box and select the Properties option. The following Properties window will appear. Select the Text tab, and under the text heading, fill in the name of the diagram. Now, let's make the border of the text box transparent by clicking on the Line tab and then checking off the Transparent checkbox. Lastly, let's change the font properties of the text box by clicking on the Font tab and then changing the desired properties such as the font format, size, and color. Click the OK button to save your changes. Now, let's add some devices to our schema. Select a breaker device icon and click on an area for which to place the breaker device. Since we'll be reusing this type of device, we'll make a copy of it on our clipboard. To do this, we'll right-click on the device and select the Copy option. We can now make copies of this breaker anytime by right-clicking anywhere on the schema and then clicking the Paste option. A new device should now appear. You may now move this new copy of a device to another part of the schema. You can also copy and move devices by holding the Control key and then dragging the copy of the device to another place. If you also press the Shift key while dragging, the copied device can be moved on the same horizontal or vertical axis. Some of the components may need to be rotated or scaled accordingly to accommodate our diagram. If the Rotate toolbar is not shown, bring it up now by activating it in the View Toolbar menu. To rotate, select the device you wish to rotate. Click on the icon representing the direction you wish to rotate the item. The device should now be rotated. Now that the breakers have been added properly, it's time to add the switches. Start by selecting the switch to add from the right-hand side of the screen. Now, place the switch by clicking on the work area. The switch should now appear. We'll make a copy of the switch since we need two of them side by side. The transformers can be added next. We'll need two transformer components, so once we add one, we'll use the same copy techniques as before to get two on the schema easily. Let's add some lines to connect the system of breakers together. Lines, like any other schema component, can be copied and moved around easily to finish up drawing the schema quicker. Once all the lines have been dropped on the screen, the schema will look like this. Additional elements such as arrows can be added as necessary. In this case, we add the arrows to follow electrical guidelines. Click on the arrow icon and then click on the work area. The arrow should now appear. You can resize the arrow by clicking on it and then dragging the corner of it to shrink the size. You can create the arrows for the other parts of the schema by using the copy and drag techniques you learned earlier. Rotate arrows as necessary. To make things easier, you can always select several components together to be duplicated. We will now add our analog parameters to the schema. We will change the appearance of this component by right-clicking on the component and selecting the Properties option. First, we'll change the border color by clicking on the Line tab. Since we want the border to be transparent, we'll click on the Transparent checkbox. Now we will change the fill color to transparent by clicking on the Fill tab and then checking off the Transparent checkbox. To save our changes to the appearance of this checkbox, click on the OK button. Since we'll need other analog values with the same appearance, let's just make copies of the component and place them in other areas of the schema. Let's also add a gauge to measure a value. We should now label various components of our system to make it easier to understand. Congratulations! We are now finished designing the look of your schema. Now that the visual look of our schema has been completed in the previous section, it is time to connect components of our schema to actual devices so that we can monitor and/or control them. We will start with setting up the gauge. Start by right-clicking the gauge and select the Properties option. Go to the Attach To tab. Pick your device in the drop-down menu. Now, pick the parameter you wish to monitor. Select a minimum and maximum value for the range of values you expect from this parameter. Click OK to save your changes. Now we will set up the analog parameters. The configuration of analog parameters are similar to that of gauges. Start by right-clicking on an analog component and then select the Properties option. The Component Properties window will appear. Select the device and parameter to hook up the component to. We will now change the font properties of the text readings from this component by clicking on the Font tab and then changing the color of the text as follows. Clicking on OK will save your changes. As you can see, the analog component now shows dashes. Now that you've seen how an analog device is connected to an actual device, we will now apply the same methods to the other analog components. The schema will then look like this when done. We will now set up a breaker to reflect the state of a parameter on the device. Start by right-clicking the breaker and select the Properties option. Click on the Automatic Radio button. Pick your device from the Device drop-down menu. Pick the category of reading you wish to monitor. In the third drop-down menu, select the actual parameter you wish to monitor. Your breaker is now configured. Click OK to save your changes. Lastly, we will set up the breakers to appear green when they are in the open state and red when they are in the closed state. You can choose any colors you want, however. Right-click a breaker and select the Properties option. Within the Manual Indication section, select the colors for your on-off states. Click OK to save your changes. Now repeat this process for all the other breakers you wish to configure. An easier way to perform this task would be to copy and paste this breaker with these manual properties to different areas on the schema. Now that we have set up all the components in our schema that require monitoring, it's time to set up the control components. In our schema, there is only one component that is required for control. This component is the breaker highlighted here. To set up control, follow these steps. Right-click on the breaker and select the Properties option. Select the Controls tab. We will now set up two commands for Control 1 and Control 2. Let's fill in details for Control 1. Click on the Enable checkbox to begin. Then fill in the device and corresponding parameter you wish to control, as well as what value you will be sending to the device. Now let's repeat this process for Control 2, except we will be sending a different value from Control 1. Even though our device is set up for control, a change in state is not necessarily automatically reflected on the schema. A simple way of viewing the state of the parameter that is being controlled is to set up the breaker to automatically read back the state. Here's an example of how we can configure this breaker to reflect changes automatically. The important thing to remember in this case is that you should configure the same parameter for monitoring as you did for control. We are now finished setting up this breaker, which is being used for control. Click OK to save your changes. We will now conduct a general test to see if our schema's monitored components are connected and configured properly. The system editor command we will be using is the one-shot test. The one-shot test is designed to perform a one-time poll of analog and digital values from actual devices that we have configured, and then to display those values on our schema in the system editor. It does not, however, validate whether or not our control components are set up properly. To check our control components, we'll have to use the system viewer. To perform a one-shot test, just click on the one-shot test icon on the toolbar. After a few seconds, the devices will show their current state and/or values. As you can see, our monitored components are being read properly as values and states are being shown on our schema. You can click the one-shot button several times if you'd like to retrieve additional readings. Congratulations! You have now learned how to use the System Editor tool. You can now save your drawing so that it can be used in the System Viewer tool later. Once we've created our custom HMI screens, we can view them with the OneLine Viewer. The toolbar at the top of the schema area contains all the tools you will need in the System Viewer. This includes opening schema files, viewing device status summaries, and navigating between multiple viewable pages of a schema. Along the bottom of the schema area, you will see tabs which allow you to easily switch between viewing various schemas that you have opened. We will be using the schema file you created in the System Editor. To open the schema, click on the Open File icon on the toolbar and select the schema. Click the Open button to open the schema. If the schema has been designed, connected, and configured properly, you should be able to immediately see real-time values of the monitored components. View Device Status tool. Assuming that you've loaded your schema properly, to activate the View Device Status tool, click on the View Device Status icon on the toolbar. A window should now pop up showing you a list of your devices and parameters, as well as a summary of all your device and analog digital points. The green indicator beside the device indicates that the System Viewer is retrieving data from the device correctly and completely. You can drill down into a device and view all its parameters by double-clicking on a device in the Device Parameter list. All corresponding parameters of that device should now appear below that device. To the right of each parameter, you can see the corresponding real-time value or status. At the bottom section of this device status window is a summary of the status of your devices and analog digital points according to 3 headings: online, offline, and invalid. The online status count means that the schema device is configured properly and is communicating with the actual physical device. The offline status count means that the schema device is configured properly but is not communicating with the actual physical device. And the invalid status count means that the schema device is not configured properly, so it cannot communicate with any physical device. Control. In this schema, there are 6 manual indication controlled breakers whose states are manually set in the viewer. There is also 1 automatically controlled breaker whose state changes automatically within the viewer to reflect the value on the device. Finally, there is 1 control breaker whose state is changed on the physical device via commands sent from the System Viewer. This state change is also automatically reflected in the viewer. We will now go through the steps on how to utilize these various types of breakers. Let's start off with the manual indication controlled breakers. You can change the state of a manual indication controlled component by clicking on it and then selecting OK at the prompt. As you can see, the breaker will toggle states. In terms of automatically controlled components, the System Viewer cannot control them since their state is determined by the value of a specific parameter on the device. Lastly, we can send commands to a device to initiate control. We do this by clicking a device configured for control and then selecting which state you want the parameter to be switched to. Control is a two-handed approach. This means you must use both hands to issue a control command, and in the viewer, you must hold the Control key and click at the same time. A confirmation box will appear once the control command has been completed. Introduction to the Annunciator. The Annunciator tool is used to create and view visual dashboards or alarm status screens so that an operator can monitor and acknowledge the status of their remote sites and devices, all on one convenient screen. Upon accessing the Annunciator screen from the main menu, the following screen will appear. The Annunciator toolbar at the top contains an assortment of tools used to perform file management, alarm alert acknowledgement, and configuring of indicators. Along the bottom of the Annunciator area, you will see tabs which allow you to easily switch between viewing various Annunciator screens that you have opened. Now that you're familiar with the interface for the Annunciator, you're ready to go through the various features of the tool. You will be learning about the following aspects of the Annunciator: inserting an indicator, configuring an indicator to a device, configuring an indicator's alarm settings, acknowledging alarms, resetting an alarmed indicator. Let's start off with learning how to insert an indicator onto the Annunciator panel. To insert a new indicator into the Annunciator panel, select the Insert icon from the toolbar. A new indicator should now appear. Note that there are no devices configured to this indicator yet. You have now learned how to insert a new indicator into the Annunciator panel. Now let's move on to how to configure an indicator to a device. To configure or edit an indicator's properties to a device, follow these steps. Select the indicator you wish to edit and click on the Edit button on the toolbar. The following properties box should now appear. Under the Setup tab, fill in the following information: display name, device to attach this indicator to, whether or not this indicator is measuring an analog or digital value, and lastly, select whether or not you want to log events. We will now look at how to configure the alarm setting for this parameter. Now, select the Active tab, and the following screen will appear. Fill in the following information. Select the high-end or low-end conditions that, when met, will trigger the alarm to go off for this indicator. Select the latency period, which is the amount of time a value has to be in the alarm state before the alarm is triggered. Now, let's set up the alarm color settings. Click on the Color tab and select the color that will illuminate the indicator should the high alarm condition be met. You can also select the color to show if the device meets the low conditions. Now, let's set up the alarm audible settings. Click on the Audible tab and fill in the following information. Select whether or not you want to play a sound file when the alarm is triggered for this indicator. Select the sound file to play. Select the frequency repeatability of the indicator when the alarm is triggered. Now, let's set up the alarm reset mode. Click on the Reset tab to fill in the following information. Clicking Manual means that the indicator's alarm has to be manually reset with the Reset command once an alarm is acknowledged before it can return back to its normal condition color and state. Selecting Automatic means that the indicator's alarm is automatically reset when the indicator is acknowledged and the readings of the indicator are back to normal state values. You have now learned how to configure an indicator's alarm settings. We will now talk about how to acknowledge alarms should there be an alarm condition or state. When an indicator is monitoring the devices and the values within the device exceed the alarm settings of the indicator, an alarm setting is triggered and the indicator starts blinking. To acknowledge the indicators on your Annunciator panel, which are in an alarmed state, click on the Acknowledge button on the Annunciator toolbar. All active alarms should now stop blinking, though they will stay in the alert color until the alarms are reset. Let's learn how to reset alarms now. An indicator in an alarm condition can only be reset back to its normal state under the following conditions. It has been acknowledged. The indicator's alarm reset mode parameter has been set to manual, and the current readings or values from the indicator are no longer in the range of values that trigger the alarm state. To reset an alarmed indicator, click on the Reset icon. The indicator will now return to its normal state. If the indicator was originally configured for automatic reset, the indicator will return to the default color when the current readings or values from the indicator are no longer in the range of values that trigger the alarm state. You have now learned how to reset an alarmed indicator. You should now have a general understanding about the functionality and capabilities of the Annunciator. The Administrator function allows us to enable security functionality for our HMI and create user accounts with various levels of security. Upon entering the User Administration tool, you will come across the following screen. This is the main setup screen in the Administration section. The left portion of the screen, which we'll call the Group User List, is used to list all access groups and users of your system. The right portion of the screen is used to show the details of the access group or user selected. By default, the Access Group Administrator and the User Administrator are created in the program. These cannot be deleted from the system since the program allows only one user with full administration rights to be present in the system. No additional users can be added to the administrator group. There is also a default operators group to which new users can be added. This group can be deleted. It is important to remember that the program requires every user to be associated with an access group. In fact, let's walk you through how to add access groups and users now. To add an access group, begin by clicking on the Add Group button above. Upon clicking the Add Group button, a new access group is created, and it will now appear within the group user list. As you can see, the default name for this new access group is New Group 1. We will now change the name of this access group to Engineers for this example. On the right portion of the screen, the details of the newly created access group, such as permissions, group name, and comments, are now visible. The permissions checkboxes of a group determine the maximum access rights users in this group will have. For example, if the Engineers group had the device setup and Annunciator checkboxes checked, all users in that group will be able to view and use at most only the device setup and Annunciator features of this program. Any details of this access group can be edited to your liking, and all modifications are saved automatically by the program. You may edit the details of your access group at a later time by selecting the access group and changing its details in the description panel on the right. Congratulations! You have now learned how to add a new access group. If you wish to delete an existing access group, select the group to be deleted in the group user list and click on the Delete button. Just note that when you delete an access group, all the users belonging to that access group will also be deleted. One more thing to remember is that the default access group administrator and its corresponding user administrator cannot be deleted. Now let's go into the procedure for adding a user to this new access group. We begin by showing the user management screen where you can see the Engineers group you have already created. To add a new user to this access group, you must click on the access group to which you want to add a user. In this case, it is the access group called Engineers. Once selected, click on the Add User button. Your screen should now look like this. As you can see, a new user has been created, and this program now requires you to enter the details of this particular user in the right portion of the screen. You should begin by choosing permissions for this user by selecting the checkboxes to reflect the permissions you want to grant. By default, new users will be assigned the permissions of the group to which they belong. Once those details have been filled in, it's time to fill in the contact information of this user, such as their name, email, telephone number, and comments. Finally, the user's authentication information must be completed by entering their login name and password. Please confirm the password by retyping it in the Confirm Password field. This user has now been automatically saved by the program, and you can now choose to add, edit, or delete another access group or another user. Congratulations! You now know how to add new users to an existing access group. You may edit the details of your access groups anytime by selecting the access group from the list on the left and changing its details in the description panel on the right. The changes are automatically saved by the program. Anytime you want to delete an existing user, just select the user to be deleted on the group user list and click on the Delete button. You have now learned how the administration tool works. By clicking on the OK button, your changes will be permanently saved and you will return to the main screen of the program. If you do not wish to commit your changes, you can click on the Cancel button to return to the main menu screen of the program without any changes being saved. Not all Enervista functionality was demonstrated, but you should now understand the typical capabilities of an advanced HMI.